Hi. So this is the financial rag work QI built. So it gives all the information. This is just the basic information on it, and this is the repo which contains the code. Okay, and as you know, this is the whole architecture where you submit document, data structure happens, the chunking happens based on which of the embedding model you use. You can choose any one of them, and which you store it in a vector database, and based on a given query you get the best possible top choices from that chunk, and using that chunk you try to answer it using a streaming system, or you can easily fall back to a given text to just get okay which is the text which is giving the answer. And the best part of it is it's always grounded on the document which we have. Okay, so let's try to use this. So this was the one, as you can see, and let's try to build this. Okay, just give it a second. So it's starting the UI. Okay, and good. And let's use, so this is the amount of documents or amount of chunks it can use to answer a given query. So the bigger, the more amount of chunks it uses, the more grounded it is, and but the more costly it is because your context window increases. And I finally am using a GPT model to answer my final query. Okay, so okay, let's not use by latest because this is a bigger model and it will take around 16 minutes just to create all the embeddings and set it up. So let's use the base one. Okay, and what I need to do is you need to copy the API key, paste it here. The API key has been restored, and let's get the document up. So which was the accounting book one. So when you process a document, you can say it's setting up the rack system, it's running the system. So as you can see, it's extracting from the PDF, and everything happens quickly. The maximum number of time required is creating the embeddings, and you can see here this is why it takes a long time, because I need to create a large set of embeddings which will take around 5 minutes. So in that 5 minutes I will quickly explain how everything works here. Okay, so okay, let's try to explain this. So the flow that we have as Rolio, the idea is that from a PDF we break a document. So imagine you have, for example, this document which we have this accounting one was, I think, 1,000 pages or something. And then now the point is you can't run the whole LLM on it. So what you need to do is you need to chunk it into smaller text bits, and then you can optimize or you can look up using the rag on the exact documents you exact chunk part there is for a given query, and then get your answer. So as you see, there are multiple models here. So there is BG model, which is best for retrieval augmented generation, but there are multilingual E5 also which can be utilized. So as you can see here in the top, you can choose which model you want to use for the given system, how much context window you want, the API key, and you can just allow the process to run through. And moreover, the cost here. So as you can see, the reason why it's taking so much time is because it's running it on a CPU. I'm running it on my MacBook, and MacBook does not give you NVIDIA systems, right? So I don't have a GPUs to run you know processes as of now embeddings. So this is the reason it's taking a bit more time, because fundamentally you're broken the whole PDF into smaller bits, and now what you're trying to do is getting the embeddings, summary embed, passive passage embeddings out of them. So when you have query embeddings, you can fetch what you require. Okay, so just let's give it 1 minute, and we can actually use BGM3, which is the latest PG model here. As you can see, I am using the base model. If I use the latest model, it will be better because the context window is pretty big. So right now, the context window, or the word for which you can create embedding from any model, is around 500 words, 500 tokens. whereas the BGM3, the latest model, gives you 8,000. So which is tremendously more. So it's actually really good, as I've shown here. For BG, it's 1,500 tokens, but it's way less for the other ones. But anyways, so let me tell you how the process happens. So we have the Streamlit app file, which takes the query and given the API key. First, it gets the data for the rack system, defines the rack system, get the get all the uh, documents which make up that RAG results, and once it has that RAG results, here you can see. Let me go down. So you can see, so here when you retrieve, so submit with the API key, you generate, you give the you submit with the API key, you generate all the answer, and once you have all the uh, retrieved components which are from the vector database, use all of them together combined. So you combine all of them together to see, okay, which of them could be used for answering your question. And the reason why it's so grounded on it is because how you define your uh, prompt. So here in my case, you can see in my prompt, this is my system prompt, and I've decided, as you can see here in the prompt, it says only answer if the question is there in the context. If the answer is not in the question, as you can see, I can't find the results in the provided documents. And you also need to give the pages where you find the given answer, so it makes sure it's grounded. So I hope it's done. Yeah. So you can see the loading has happened. So if you see here, all the models data has been loaded. So there are 2,700 chunks created out of that big CSV. Okay. So okay, these are some questions. So let's try the first one. Okay. And yeah, as you can see, it takes the top 20 documents, and these are the top 7 ones which are trying to help answer the question, how is revenue recognized on the accrual basis of accounting? So this is the answer. What is gap? And now if you ask this question, GPT would be like, I don't know. But here it exactly knows what gap is, because this definition is properly available in the PDF, right? And that's the reason it's able to answer the given question. And it tells which page number 57 and page number 992. That's where the information is exactly present. That's how it can answer. So what are the components of the main sheet? Again, you can ask any question. I've just saved these 5 questions, so it gives all the components of the 5 sheet, because uh, it retrieve all the documents, all the information from the PDF, because through the RAG system, and it tells it uses page number 656 to answer the given question, which presents a balance sheet example. So page 655 has a balance sheet example, and that's how it was able to answer it well. And let's see. So any question can be answered with it. And yeah, you can see, okay, this is a very good trick. So you can see this one was not able to answer the question, but let's increase the number of documents. So for example, let's use 27 documents to answer the question instead of top 20 documents. So now it's actually picking up 27 documents, and now you can see it's able to answer the question, because there are multiple documents present or chunk present in the system, and you pick the 27 of them and then try to answer the given question. And from top 27 question, this was able to answer the given question. And again, if you ask him very, who is Donald Trump, and obviously the model would know, because GPT-4 Omni is running in the background, right? But still, if you ask who is Donald Trump, it should not be able to answer it. I cannot find the answer in the provided document, because no document, the PDF which we have, is not able to answer this given question. But yeah, so where is the return shown in the financial statements, and yeah, it tells you the exact answer. So it uses 27 top documents, it retrieves, and it tells you that okay, this is person from page number 817. So it's packed on the data, and this is how it's able to retrieve the data well. So again, this is the whole flow. You can choose which model you want. You can reduce the number of documents to be used to answer a given question, but generally it's better to have as much many documents as possible, because the cost is pretty low, as I've already told the cost here. So for example, for every prompt, the approximate cost would be around $0.01 per prompt when using 4 GPT-4 Mini. So the cost isn't very large if you use all 30 max size. So the cost is $0.001 per prompt. So it's not very, very large in that way. And yeah, this is the whole system. You can test it, you can run it. What you will only need is this API key, which you will have to have your own to run it. And with that, you can get your answers. So yeah, that's all. Thank you.